All right, happy Wednesday, pre-calc students. We're going to begin chapter 11 today, which is going to be all about graphing in 3 dimensions. All right, so first off, the substitute should have handed you out um, some 3 dimensional graph paper, a couple of slips for each person, and you're going to be able to tape those right into your notebook. And we'll use this in some examples here in just a moment. All right. But you can see that this graph paper is a little bit different than graphing in 2 dimensions, right? It's kind of made up of a bunch of little triangles, but we'll show you how we can utilize this to actually graph in 3 dimensions here in just a moment. All right. So let's jump into things. Our chapter 11 is going to focus on, again, graphing in 3D. And so we just want to recognize that as we move from a 2-dimensional system to a 3-dimensional system, right, we're basically looking at, instead of just one plane, right, when we think about their coordinate plane, X and Y, we just have one plane. But now we're going to work with a third dimension, which means we're actually going to have 3 planes, right? So when you look at this diagram, you'll notice 3 different colors. And so the orange color, that's really representing our XY plane, all right? Positive X is moving towards us, essentially. Negative X is moving away from us. And then we have our Y-axis, all right, making up the other part of that orange plane. And so, again, positive Y is moving to the right, negative Y is moving to the left. And then we have this Z-axis, all right? And the Z-axis, moving up is positive, moving down is negative. And you can almost see that if you look at that graph paper, you see those 3 axes represented by those black lines, all right? And so, again, we have the 3 planes. The orange plane representing the XY plane. The blue plane would be the ZY plane. And the green plane is the XZ plane, all right? Now, these 3 planes, as we look, it actually divides our 3-dimensional coordinate system into 8 different parts, all right? And those 8 different parts are what we call octants. Oops, forgot to turn my pen on here. My apologies. All right, but these 8 different parts are what we call octants. And so I want to buzz through the octants here real quick and think about what it means for each part of a point in 3 dimensions. So when we plot a point in 3 dimensions, instead of using a coordinate pair, we're using a coordinate triple, right? So we have an X, Y, and a Z. And so when I think about my octants, right, my first octant, I use Roman numeral 1 here, all right, just like my first coordinate, well, that means that everything is positive. So I have a positive X, I have a positive Y, I have a positive Z, okay? Now, when I move into my second octant, all right, just like on my coordinate system, well, what's going to change here is X is going to become negative, Y stays positive, Z is going to stay positive, right? So if we think about this, if you can visualize this in 3 dimensions, right, octant 2 is sitting back here, all right? So this would be octant 2 behind the blue, above the orange, and to the right of the green, okay? Octant 1 is sitting right here in these spaces all around. Right towards the front of us, right? Above the orange, in front of the green, and in front of the blue, okay? Octant 3, all right, well, again, we're basically rotating around our XY axis, just like we do with our coordinate system. So in octant 3, we have a negative X, a negative Y, and a positive Z, right? So we're sitting back here, so to speak, right above the orange, but behind the blue, behind the green, all right? So octant 4, this is where X is back to positive, Y is negative, Z is still positive. All right, so this would be octant 4 right over here, okay? So above the orange, in front of the blue, and basically to the left of the green. All right, so you can see we rotate around on the XY plane, above it first, and then to get our next octants, we're going to drop below this plane. All right, so if I go to octant number 5, that's going to exist down here below the orange, in front of the blue, and to the right of the green, right? And if I think about what that means, well, I have a positive X, I have a positive Y, but now we're going to see all the rest of my octants, Z is going to be negative, okay? So now if I move to my next octant, octant 6, oops, there we go, octant 6, right? We're going to rotate again, basically around in this, just like we typically would, counterclockwise fashion. So octant 6 is going to give us a negative x, a positive y, a negative z. All right, then I'll move into octant 7. That's going to be hanging out back behind here, right? So it's almost like if I'm back behind all of this, I'm back in that area, right? That would be octant number 7. And in octant number 7, we're going to have a negative x, a negative y, and a negative z, okay? And then we move into octant 8. Well, this is octant 8 down here, right? The last of our octants. There we go. And so octant 8 is going to be a positive x, a negative y, and a negative z. All right. Now, at the end of today's lesson, I'm going to have you do a little activity. You're going to create an actual three-dimensional model using some paper and scissors that are on the black cart. And there's a handout in the Google Classroom to help you do that. And I think this will help you guys kind of visualize where these different octants are at. All right. So now let's go ahead and talk about modeling in 3D. So let's utilize that graph paper. And I just want to talk through how to plot points in a three-dimensional plane. Okay, so let's start out with point A here, all right? Now, notice that point A has a positive x, 0y, and a 0z, right? So this point is basically just going to exist on the x-axis, right? Now, as I look at this, this system here, let me change my pen color here for just a moment. Let's go to black, all right? So this axis right here, this is our x-axis. All right, this axis is our y-axis, and this axis is our z-axis. All right, now notice the directions. It says when you move in the xy plane, we want to do that first, and we're going to leave a trail, and then we're going to move up or down for z. So let's go ahead and plot some points. Let me change my pen color back. Let's go back to red. We'll plot point A first in red. All right, so if I'm going to move and plot this point, I'm going to move on my x-axis 3 units in a positive direction. So I'm moving, visualize that as coming towards us, all right? And so I'm going to move 3 units, 1, 2, 3, and that is my point right there, right? I've only moved on the x-axis, all right? So 0x or 0y, 0z, okay? So let's change colors again and let's plot point B. So let's do plot point B. Do that in green here. All right, so point B, now I'm 4 units on the x-axis, right? So 1, 2, 3, 4. And now I'm 0 units on the y-axis. So right now, my I'd be running parallel to my y-axis if I need to plot that point. So kind of running on this line, but I don't have any values. So I'm staying on that axis. And now I'm moving up 4 units in the z, all right? So 1, 2, 3, 4. All right, now in 2 dimensions, it looks like this point is sitting on the y-axis, right? But again, that would be on a 2-dimensional piece of paper. So it's hard to represent things in 3 dimensions on a 2-dimensional piece of paper, and that's why we need to leave the trail, right? We're trying to communicate, hey, we've actually moved down on the x-axis, and then we've gone up. Right, and you can see how that graph paper hopefully works a little bit now, okay? So let's plot point C. All right, we'll do point C in green, or in blue here. All right, so point C, I'm moving 2 units on the x-axis. All right, now I'm going to move 3 units in a negative direction on the y-axis. So negative direction is this way. There's 1, 2, 3. So you can see how I've now moved in the XY plane. All right. And now I want to move 5 units on the Z plane. So that's following this line. I'm going to move up 5 units. 1, 2, 3, 4, and 5. And this would be point C. All right. Now, I can name the octant of this point, right? So if I think about my octants, again, when I'm above the XY plane, right, it's 1, 2, 3, 4. This is sitting over in the 4th octant. of that graph paper. Okay, and I know that because x is positive, y is negative, z is positive. That puts me in the fourth octant. Okay, now let's switch over to another color and let's plot our fourth and final point. We'll go with magenta. It's an exciting color, right? So -2 on the x-axis. I'm 6 on the y-axis. So 1, 2, 3, 4, 5, and 6. All right, so I'm right on the edge of my graph paper. All right, so if I think about my coordinate plane in terms of just x, y, I'm sitting in the second quadrant, right? And now I'm going to move up 2 units for z, 1, 2. Here's my point. All right, and I can see that I am now sitting in the second octant, all right, because x is negative, y is positive, z is positive, okay? And so that's how we're going to use that three-dimensional graph paper to plot points, okay? Now, think about something else that we oftentimes do in math, right? Is let's say that we wanted to find the, let me change my pen color here. Let's go back to black. But let's say I wanted to find the distance between points C and D, right, in this three-dimensional plane, right? So I want to find the distance between them, right? They're sitting in different octants, and it's hard for us to visualize on a three-dimensional piece of paper. But really, when we think about the distance formula, even switching to 3 dimensions does not change what that formula looks like, right? So if you take a look at the formula here to find the distance between two three-dimensional points, is I want you to notice that it's really not any different than our distance formula of old, right? If I look at just this part of the formula right here, right, this is just our two-dimensional distance formula. And all we've done is followed the exact same pattern that we used for x and y and applied it to z to find our three-dimensional distance. All right, so let's just put this to work. Take a look at an example problem here. All right, so let's say we wanted to find the distance between the point 419 and the point, the order triple 216. Okay, so we're just going to set up in our distance formula just like normal. Life is pretty simple, even in 3D, right? So it doesn't matter what you consider point 1, point 2, just as long as you're consistent with it. So let's say this is point 1 and this is point 2 here. So if I'm following the formula by the letter of the law, right, we would say 2 minus 4 quantity squared plus, find the change of my y's. Well, since y is the same in both points, that change is going to be 0. And then I find my change in z, which is 6 minus 9 quantity squared. All right, so just simplify some things down here. 2 minus 4 is -2. -2 squared is 4. Change in y, we already mentioned, well, there isn't one. That's why it's 0. Plays out that way in the formula as well. And then the change in z, 6 minus 9 is -3. -3 squared is 9. And so we end up with the square root of 13 is our distance formula. Okay. All right. Well, that is your basics to 3 dimensions. So here's your homework assignment today. And then before you finish class today, I want you, and get a start on this right away, you'll partner up with somebody. If you look in the Google Classroom, there is a handout for creating a 3D model. And all the supplies you need should be on the black cart. And so I'd like you to partner up. It'll take 2 sets of hands, so you need 2 people to put this together. But I think you will find this helpful. So once you get done creating the model, and there's an example on the black card as well, I would encourage you to label your plane just like we have here. All right? And that will just help you to identify the octants as you think about each of those planes in there as well. All right? You guys have a great day, and I will see you tomorrow. Again, access that handout and get that model created as well, and we'll be good to go.